Okay, now let's look at another question on relative velocity. Now, this question is using the position vector I and j. Okay, in terms of velocity vector, is also used I and j. Okay, this is slightly different from the previous two questions that I have discussed. Now, let's start off by defining the velocity vector. In this case, we are looking at the velocity of ship P. Okay, we state that the ship is sailing at a direction of northeast. Northeast means at a bearing of 45 degrees. Okay, so now let's look at the question asks for the velocity vector of P. That means in this case, you want the velocity to be split into two. One is I and j direction, both. So let's draw out the velocity vector diagram. Vp tan square root 2, but this velocity can be split into the vertical direction and the horizontal direction. Okay, so given this as the diagonal of the triangle with a 90 degree in here. Okay, so the velocity of P in the vertical direction basically is the j is actually tan square root 2 sine 45. Okay, since this is the northeast direction, so this 45, this also 45. Okay, so you work it out, it's tan square root 2 sine 45 is also 1 over square root 2, so cancel out the square root 2, you got tan j. Similarly, you look at a Vp in the horizontal direction. Okay, and you can convert into tan square root 2 cosine 45, which give you also a tan I. So if you want the velocity vector of P in terms of I and j, it would be velocity vector of P is tan I plus tan j. So this is answer for part 1 of question 38. Okay, now let's go and look at the position vector of P at 12:00. I mean there's 2 hours after when it's at this position here. Okay, now let's look at the common definition of position vector P at t hour after 10:00. Okay, he's saying is 12:00. That means 2 hours after 10:00. So first off, let's look at the position vector at t hour. So basically, you have the initial position at the 10 hour plus the velocity vector of P times the time. So this is you taken from here. There's the initial position at 10:00. Okay, then plus the position vector of P, which we already break down into I and j in this case, and then the t. So at 12 noon, which is 2 hours after the 10, so is you change the t become 2, so simplified you get 16i plus 28j. So this will be the position vectors of P at 12:00. Okay, now the next question is asking is before we go to the next question, is saying that another ship leave at point B at this position vector and with the velocity vector of this. That is at 12 hours. Okay, that means the time counted for Q is 12 hour. Okay, that means from 12 hour, at 12 hour the time is considered 0 for Q. So we're going to use this as a reference rather than at the 10 hour in the later part of the question. Okay, now let's look at this velocity of P relative to Q. So velocity vector for VQ, which we have worked out, VP is 10I plus 10J. For VQ, which is given, is 8I plus 6J. Okay, using the standard formula equation, and we want to find V relative to Q. So we're going to use this, making V PQ as the subject. So VP, this bring over become minus VQ. So when you substitute all this VP vector, velocity vector P, and velocity vector Q inside, you got 2 plus 4J. Okay, so our velocity vector of P relative to Q is 2 plus 4J. So to find the magnitude of the velocity of P relative to Q is just taking square root of 2 square plus 4 square. Okay, that means you got a 2 here in terms of magnitude in the I direction, and you got a 4 in the J direction. Okay, so to find this magnitude, you just square of this plus square of this as square root sum. You get 2 square root 5. That is the velocity vector, the velocity of P relative to Q. Okay, let me repeat. Is the velocity, D is 2 square root 5 is the velocity of P relative to Q. D is not in terms of positional vector. This is just the value of velocity of P relative to Q. Okay, so this is the answer here. Now, but giving the magnitude of this velocity of P relative to Q is insufficient. Why? Let's see the rate working. You also have to define the angle. Velocity of P relative to Q means Q is stationary and P is moving. Okay, now we have to define the angle as well. So the angle would be this 4 from the velocity vector. We can define the angle. This 4J, this 2I. So from here, if you work out this angle is the bearing of this. The 2 arrow is the velocity of P relative to Q. Okay, this is the velocity of P relative to Q, and it can be actually can be split into 2 velocity, which is 4J and 2I from here, 4J and 2I. And the angle can be calculated using the 4 and the 2. And if you want bearing of this relative velocity P relative to Q, then you have to take this bearing. So this is actually equal to this. So this angle is a tangent 2 over 4. Okay, tangent 2 over 4, which gives you 26.6 degree. Therefore, a complete answer for velocity of P relative to Q is equal to 2 square root 2 at a bearing of 26.6. Okay, this complete this part of the question, part 3. Okay, now the part 4 of the question is find the time at which P and Q meet. I mean, for them to meet, they must have the same positional vector at certain t time. Okay, so we're going to use this. For P and Q to meet, the position vector of P must equal to position vector of Q after time t from 12 noon. The definition for t here is no more from the 10 hour, because this Q only started at 12 hour. Therefore, we're going to define the t is from 12 hour onwards. So we're going to look at the position vector of p. At the 12 hour, the initial position vector of p is this: 10I plus 28j, and then plus the velocity vector of p is 10I plus 10j, and then multiply by t. And for q, you have the initial position vector, which is here, and then plus the velocity vector, which is taken from here, and t. Okay. Combining all the similar term on the left hand side and right hand side, and then equating the I vector, we got 16 plus 10t, and equal to 19 plus 8t. You work out to be t equal to 1.5 hour. To verify this, you can compare the j vector. Okay. So on the left hand side is 28 plus 10t. On the right hand side is 34 plus 6t. Work it out. You find t is also equal to 1.5 hour. Therefore, the t equal to 1.5 hour is correct. So to answer the fourth part of the question, time for both to meet is after 1.5 hour. So it is 12:00 plus 1.5 hour, which give you 13:30. Okay, so this is the answer for part 4. That's it.